Okay, so this one we're going to look at graphing, and if you need some extra practice with graphing, just go back and look at some of those graphing videos that we did, because these are all in YouTube. Okay, so remember sine, cosine, cosecant, and secant all have normal periods here of 2 pi divided by b. Okay, sine, cosine, cosecant, and secant. Okay, so don't forget that. So when they're just normal, it's going to be a period of 2 pi. Okay, so one period of sine, okay, so we'll go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and then we're back to 2 pi. So here is one graph and one period of your sine curve. Okay, so I wrote these like this. So cosecant here is going to take the sine curve. Okay, so at pi over 2, so at 0 I'm at 0, at pi over 2 I'm at 1, at pi I'm at 0 again, at 3 pi over 2 I'm at a -1, and then at 2 pi I'm back at 0, right? But for cosecant, remember you have your asymptotes at each one of those zeros of your sine function. Okay, so at pi over 2, at 1 here, I'm going to be opening up, and at 3 pi over 2, I will be opening down. Okay, cosine of x, so one period there, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. So at 0, we're going to be at 1, at pi over 2 will be at 0, at pi will be at -1, 3 pi over 2 will be at 0, and 2 pi will be at 1. So it's very similar to a sine curve, but it just has a different, what it looks like in that window. So secant there is going to have asymptotes at each one of those values. So pi over 2 and 3 pi over 2, I will have a asymptote. So I'll have an asymptote at pi over 2 and another one at 3 pi over 2. So at pi will be down here, at 0 will be at 1. I'm just going to show you one side, and then pi over 2 will be on that side. But remember, it's a continuation, like it continues in that window. Good? All right, so sine, cosine, and cosecant and secant all have a period of 2 pi. If there's a b, remember your b is inside here. If you have a b, then you divide that period by b. Okay? All right, so let's look at tangent and cotangent. So tangent and cotangent have a period of pi divided by b. So a lot of y'all missed that on your test when you had to show your work, so be careful about that. So tangent of x, remember, is going to have your asymptotes between -pi over 2 and pi over 2. So -pi over 2, we will have an asymptote, and pi over 2, we will have another asymptote. Here, halfway in between there, we will have a x-intercept. And remember, tangent is going to grow. So tangent is going to grow this way. pi, we would have the same thing, like that. Cotangent has asymptotes in between 0 and pi. Okay, so 0 and pi, you will have an asymptote. And halfway in between there, you will have a x-intercept. Cotangent decreases normally. Okay, and then it continues following suit there. Okay, so remember graphing? No graphing. Okay. So then I want us to look at identifying amplitude, period, and phase shift. So amplitude, remember, is the absolute value of the number that's in front. So the amplitude for this one will be a 3. The period here will be, it is a cosine graph, so it'll be 2 pi divided by b, which is just a 1, so it'll be a 2 pi. And then the phase shift here will be to the right pi over 2. Okay. All right, so for this one, I've got 2 secant x plus a 3. So the amplitude here is going to be a 2, right? Period is just going to be a 2 pi. And then I don't have a phase shift, but I have a vertical translation. Vertical shift here, it's going to go up 3 units there. Okay. Describe the transformations here. So here we're going to have an amplitude of a 1/3. So that means that I'm going to shrink this a little bit. So it's going to get smaller. And it's also going to be a reflection. It's going to have a phase shift right pi over 2. So it's going to move to the right pi over 2. And then it's going to move up 4 units. Okay. All right, so this transformations, before I just start describing them, I need to factor out that 1/2 there. So it'll be 1/2 x plus a pi minus a 1. So the amplitude is going to be a 2, so it's going to stretch it. Okay. The period is going to be 2 pi divided by 1/2, so that's going to be a 4 pi, so it's going to expand that period of the graph. It's going to move to the left pi, and it's going to move down 1. Okay. All right. Let's look at these, and then we talk about polar graphs. So remember, convert to rectangular coordinates. So remember, what's important is x is going to be equal to r cosine theta, y is going to be equal to r sine theta. So here's my r, and here's my theta. So to rectangular coordinates, it's going to be 3 cosine of 7 pi over 4, and then 3 sine of 7 pi over 4. So cosine of 7 pi over 4 is just going to be square root of 2 over 2. And sine of 7 pi over 4 is going to be a negative square root of 2 over 2. So these points are going to be 3 square roots of 2 over 2 and a negative 3 square roots of 2 over 2. And that would be the answer I would be looking for. Convert to polar coordinates here. So I've got a -1 and a 1. So -1 and a 1 here. So I want to find the, whoops, that's definitely not right. -1 and a +1. Wrong quadrant there. So if I wanted to find the polar coordinates, we need to find our r value here. So the r value, remember, r squared is going to be equal to x squared plus y squared. And then the theta value will be tangent of theta is going to be y over x, like that. So the r value is going to be the square root of -1 squared plus 1 squared. So that'll be just a square root of a 2. So your r is going to be square root of a 2. So your radius is square root of a 2. And then your theta here, so it's going to be tangent of theta is going to be 1 over -1. So this will be inverse tangent of a -1, which is going to be in the fourth quadrant. So it's going to be 7 pi over 4. And no, it's not. That's not right. It's going to be in the second quadrant, right? So second quadrant is going to be 3 pi over 4. There we go. Good deal. Okay. Okay, and so then graph this polar equation. So I've got a sine graph here. So it's either going to be above or below the x-axis. So this one's going to go above. So it's going to go 1, 2, 3 units above here. And then half of that. So it's going to be 1 1/2, 1 1/2. Sorry, it's going to look ugly here, but this is going to be graph. And on your test, you'll just have a basic polar graph like this. So, all right, if you have any questions about graphing, let me know.